So let's say it's 2/3 x equals, let's go 8. How do you remember from class how you might solve this?
You have to get rid of the 2/3. So would you write 3/2 next to it and cancel it out and then
Yeah, so you can multiply by the reciprocal,
multiply by the reciprocal?
which is what you just told me. Now, in the past, you might have said, oh, 2/3 is multiplying x. So you undo it with division, but dividing by fractions is a little weird. And that's why generally that's not the way to do it. So like you said, you would multiply both sides by 3/2.
All right.
Now on the left, if this isn't clear, it becomes 6/6 times x. And 6/6 is just x.
All right. So.
And on the right, it is 24/2, which reduces to 12.
X equals 12. Okay.
But there's a lot of things though, like on the right here, you could have divided by 2 before you multiplied. There's a lot there. Now, let me give you a similar problem here. Let's say I ask you for, let's go 3x/5 equals 12.
Okay. So
it's the same type of problem. The question is, do you see that you could just multiply both sides by 5/3? And if you don't, we can talk about it. But if you do, that's great.
So you could just okay, yeah, I think I get that.
Now, alternatively, you could multiply both sides by 5. Maybe you saw that. And then you divide both sides by 3. I guess I'm sort of asking, like, what do you like? You're at a place where you finally get to make some choices on your own here about what would work best for you.
Could you scroll up to the first one again real quick?
Sure.
Quick.
Let me actually write it here.
No, honestly, I kind of like the last one. I feel like that's the one that takes the least amount of steps.
This one over here on the right?
Yeah.
Okay. But so if you're gonna do it that way, that is totally fine. But when I give you a problem like, I don't know, let's go -2x/5 equals 4/3. Now what do? Do you want to just multiply both sides by 5?
I mean, yeah.
And that's fine. So that's totally fine. So on the left here, you get -2x equals 20/3.
So why is it -2x on that side?
I just made it. Because the 5 only cancels with that 5 on the bottom.
Okay. -2x equals 20/3.
Yes.
So this
is where it gets weird, because let's just say, I'm gonna rewrite it over here also. Let's just say you were like, I want to divide by -2. Do you know how to interpret this on the right?
I don't
maybe, right? So now let's look at another possibility. If you haven't figured it out by now, dividing and multiplying are kind of the same. If you multiply both sides by -1/2, do you see how it's the reciprocal of this? So -1/2 times -2, that just becomes x.
All right.
And on the right, now you go ahead.
So then would you just divide the 2 into the 20?
You could divide this 2 by 20 over here. So that gives you 10. Okay, and then it becomes negative 10 over 3.
And then negative 3 1/3.
This is actually preferred now.
Oh, okay. Sweet. That's the
Okay, so what I heard is you said, well, I kind of like this, Matthew, but what we actually ended up doing down here ultimately is multiplying by the reciprocal.
Mm-hmm. Do you think we could try the first one for a problem like that?
Yeah, and that's kind of where I'm trying to veer you towards is like if I give you negative 2/7 x equals sorry, I'm just trying to come up with numbers that work here.
Yeah.
Let's see here. Equals 1/14. Okay. The best way to approach a problem like this is to multiply by the reciprocal. Like you want to undo this negative 2/7 by multiplying by the reciprocal. What is the reciprocal of that?
Negative. I mean 7. Right.
The reciprocal is the flip.
Oh, 7 over negative 2.
Yes. 7 over negative 2, 7 over negative 2. So what does the left become?
Just negative 1. Or well, it's just x.
Just x. And that's the power of the reciprocal is when you multiply a number by the reciprocal, you get itself.
Mm-hmm. Okay. So then for the next one, would it be 7 over negative 8?
It's 7 over, sorry, this wasn't written very well. It's 4, this was 1/14.
Oh,
So
my bad.
yeah.
So I guess it would be 7 over negative 28, which would become negative 1/4.
Yes.
And then we keep it as
Keep
okay,
it
so
like
we
that.
write it as negative 1/4.
Okay.
I think that's easier.
Okay. Yeah. So let me give you kind of like a couple of problems where we're going to use this approach. I'll make them slightly easier. So let's say it's 2x over 3 minus 1 equals 5/4. Okay. So now this is a two-step equation. And 2 steps means there's 2 steps to solve it. It's very descriptive.
All right.
Right. And you know order of operations. You're probably seeing this in class now. So when you're simplifying, you go this way.
Mm-hmm.
And when you're solving, you go back the other way. So you have to undo addition and subtraction first. So what is addition here?
So would you bring the negative 1 over to the other side?
Yes, you need to add 1 now.
So add 1.
Yes.
2.
So 2x over 3 equals 5/4 plus 1. So a little reminder here, how do you add fractions?
5/4 plus 1. You have
To make a common denominator.
so then it would be 12.
4 over 4.
Oh shoot, I was looking at for
You don't need to, you don't need to mess with the other one quite yet.
Okay, so 4, so that would make it 20 over or 5 over 4 plus 4 over 4.
Yes, which gives you 9 over 4.
That's 4 over 4. 2x.
So now we're back to that problem we kind of started with. And my recommendation is to multiply both sides by the reciprocal.
So then that would be 3 over 2, making it just x.
Yes.
Equals 9/4 with 3 over 2, which would then make it 27 over 8.
Perfect.
And then we just have to keep it like that. We don't have to.
That's your final answer. Okay, so let me have you try one on your own here. Let me make this a little easier. Okay, so 1/3 x minus 1 equals 1/4.
X minus 1 equals 1/4. All right. All right, I think I got it.
Okay.
So would the final answer be x equals 15/4?
Let me show the work here just in case you want to look at this later. So this ends up being 1/4 plus 1. So that's 1/4 plus 4/4. That's 5/4. So we have 1/3 x equals 5/4. Just multiply by 3/1. And like you said, x is 15/4.
All right, cool.
Now, let me kind of address what I kind of heard there, because I think that that's a good thing for us to talk about. If you wanted to get rid of all the fractions, which is also kind of a preferred step for me, you would need to multiply by the lowest common denominator. Or it's kind of the least common multiple, but what is the denominator of 1 here?
-1.
Just one. You can always write something over 1. So between 3, 1, and 4, what is the least common multiple of those? And if you don't remember what I'm talking about, it's where you write this out.
I guess 1. Oh, that.
Okay, so that. So if you multiplied everything by 12, that means you're multiplying this by 1/4 by 12. That means you're multiplying this 1 by 12. That means you're multiplying 1/3 by 12. You get rid of all the fractions. Okay, so watch this. 1/3 times 12 is 4x minus 12 equals 1/4 times 12 is 3. Now let's solve this the way you know. Add 12, add 12. 4x equals 15. Divide by 4, divide by 4. Do you get the same answer as above?
Yes.
You do. So now which way do you like best?
Yeah, I haven't had this many choices in my whole life for math.
Yeah. There's not a wrong way, but there are, paths that help you here.
I mean, I kind of.
So let me give you a problem here where I think this path should be chosen.
All right.
So you can just kind of get a feel for this. So you sent this problem over. So when you have all fractions, or all decimals for that matter, because you'll see that variation on this problem too. When you have all fractions, that's a good time to figure out the LCM. So what's the LCM of 2, 5, and 10?
10.
10. So you're going to multiply everything by 10. Now, what some students do is the correct way is actually show it on both sides of the equation, but you can just show it in one place. But until you make sure you do it for everything, okay, you got to like almost draw the lines to make sure. So when you look at this now, do you see that it's 10 times 3/2? Do you visualize that?
Yeah.
Okay. Now this is what you're doing, but over here on the right, this is what I want you to actually do. I want you to realize that you should divide first before you multiply. Call this divide before multiply. Okay. So if you divide first, that's
look at it like at the bottom where you can see it all will be 10. So I can't just look at it as like, oh, I have to multiply 2 times 5, and then 5 times 3 is 15. And then the 5 needs to be multiplied by 2. So then it would be 4/10.
As long as, so here, here's what I want you to write when you're all done. I want you to write 15 plus 4x equals 7. When you're all done, what I want you to, here's what I don't want you to write. I don't want you to write 30/2 plus 20x/5 equals 70/10. That you can do that. That like nothing wrong with that, but it's not the best way to do it. It's not going to help you in the long term because you really should divide before you multiply.
Yeah.
Okay, so if you need to, you can write this, but see how the numbers get big? When you divide, they get small. Now we had a long conversation here, but how do you solve this equation on the left?
You bring the 15 over to the right, so minus
Subtract 15.
15,
Okay,
4x equals -8, x
and then
equals 2.
very good. Now that one was kind of nice because they just gave you the number there, but like you may not get that. You may not get that. Like, what if it's 1/2 minus 5/3 x equals 9/4?
Then you have to make it 6
What is the
minus
LCM here?
27. 12.
12. Okay. Yeah. So can you go ahead and solve this one for me, please?
Sure. Would it be x equals 21 over 20?
No idea. We're gonna work it out together.
All right.
Because that now, so like the first number becomes 6. The second number becomes 20x. And then you get 27 here. So you subtract 6 from both sides. This negative goes with the 20. So it's negative 20x equals 21. And then you divide by negative 20. So x equals negative 21 over 20.
All right.
All right, so let's look at another problem you sent me that's kind of related.
Negative.
Yes. Yes.
Dividing it over.
Yes.
All right.
Okay, so when you look at this problem here, 2/3 x plus 7 plus 1/6 x equals 12. You want to either write it or visualize it with 1 on the bottom. Okay, and this is yet another example of when you really want to multiply by that LCM.
Yeah, which would be 6. What I'd do first before I do that is bring this over to the 12.
Okay, that's a good step here. I have no problem with that. It doesn't change that you really do want to get rid of the fractions. So you're gonna multiply everything by 6. So give me your next line whenever you're ready for that, please.
All right. I mean, then that would give you 4x plus 1x. So would I write that as just x or 1x, or does it not matter?
It doesn't matter. You'll eventually equals. Go ahead.
30.
Yes.
So all right.
5x.
5x equals 30. X equals 6.
Very good.
Okay, this isn't too difficult. Yeah, I guess my math teacher, she's not like the best when it comes to like explaining stuff. So she kept I kept asking her different ways to like do it, kind of like this. Every time she'd go like, oh yeah, that works. And then she wouldn't explain it. So I was like, oh, she's just messing with me or something.
Yeah, the more math you take, the more you do get some choices. Because there's no defined rules here. It's not a recipe. It's not ABC. It's if you ever get a car that you're going to work on, like you kind of get to choose what you do to work on it. It's it's a car. So let's look at a few more of these just to make sure you've got it. And then we need to look at another couple of types of questions also here. Okay, so I saw this one. Now that you kind of have a better sense of how to solve these, what is your first step here?
You're gonna want to get all of it to 6. So that would give you 2x minus 1 equals 3.
Yes.
And you're gonna want to add 1 to both sides, which gives you 2x equals 4, and then x equals 2.
Okay, good. All right. So I'm gonna transition to another style of question that I saw here. Let me find it here. Actually, I'm going to vary it from what I see there because I don't know why they did it. But let's say you have 6x minus 1 over 3 equals 4/3. No, that's not good. Sorry, that's not going to help. Let's go 6 over 7. We'll make this really tough. Okay. Based on what you know, what would be your first step here?
Make both of the denominators be 21.
Okay.
So
that works. That does work, but I'm going to show you another path here because I think you'll like it. There's this thing that's sometimes called a butterfly, which you can multiply diagonally.
Oh, yeah.
So you can take this 7, but you got to multiply it by everything, 6x minus 1. So I write it in parentheses. And you take this 3 and you multiply it by 6.
Mm-hmm.
Now you get the same answer as what you were about to do, but a lot of times this is easier. Okay, so you add 7 to both sides.
And okay, I kind of like that.
Yeah, the advantage here is you tend to get rid of the fractions. So if you can't tell, that's my preferred approach, is to always get rid of fractions until the last step. I mean, I can't get rid of them here. That's what the answer is.
Yeah. And then you just get to keep it like that.
Yeah. So let me write your problem here on the left and see if let's go negative 3x plus 2 over 5 equals 16 over 9. And I'd like you to solve this on your own, please, or at least give it a try.
Okay. Mm-hmm. All right, I think I got it.
Okay, so I'm going to show the steps here. It's 9 times minus 3x plus 2 equals 5 times 16. So that's negative 27x plus 18 equals 80. Subtract 18 from both sides. So you have negative 27x equals 62.
And that will get you x equals negative 62 over 27.
Yes. All right. So I've got your assignment up here, or the thing you sent me. I guess I just need to give you more difficult problems here. Maybe we'll notice something if I do a few of these. So let's say it's 3/4 x minus 7/3 equals 5 over, let's go 5 over 20. Nope, that's not going to work. Sorry.
It's okay.
I gotta find ones that.
Is this the same style problem with the one we just did?
No, this one's slightly different.
Okay.
So I'm just trying to see, because otherwise you may have to give me another topic for us to work through, because you kind of have this down. But let's try this one.
Okay, cool. I mean, I do have this other thing, like the teacher said, like she just gave it to me because like she gave it those 2 papers she gave to us like to do for like 3 days, which is a little long.
Wow, seems like about 25 minutes worth of work, which we just did.
Yeah.
Yeah.
I got this other paper where it's actually, I think it might be like it's almost the exact same stuff, if not the same stuff, where it just has more numbers in it. Where it's
Okay.
like one of the problems is 1/2 plus 2/5 t minus 1 equals 1/5 t plus t.
Yes. So that's kind of stuff we're doing. Why don't you take a picture of that and send it over by email? And then while that's sending, you can work on this one, and I'll look at it and kind of see if there's something else here to work through.
Sounds good. Then here, I'll just like censor out my answers for this.
Okay.
All right. All right, just send it and
Okay. All right, I'll take a look here. Again, this is 3/4 x minus 7/3 equals 5/16. I would recommend using the LCM approach.
Mhm. Wow, yeah, this is a little bit harder than I thought.
So
Just
you got
trying to
your,
find that LCM.
yeah, now the technique here is to actually look at the biggest number and
Mhm.
start multiplying by it and seeing like, does 32 work for 4 and 3?
No.
It does not. It works for 4, but not 3. So then how about 48?
Oh, yeah, that does work.
Yeah, so you're gonna multiply everything by
12. I mean, 48. I mean,
48. Yes.
yeah, sorry.
It's got to be the LCM.
16. Okay, x equals 127 over 36.
Okay, let me just confirm here. So the first one, you should get 36x minus 16 times 7. So that's like 112. And then 48, so you get 15. So I think I heard x equals 127 over 36.
Yes.
Great. Okay, so we have a choice here. I did just look over that sheet that you sent me. We can go through and do these. I can do some, you can do some. I'm happy to do that. You could pick and choose, or we can move on to just something else altogether. With the time, you are the customer, so you get to decide that. I think we should do a few of these, but maybe not all.
Yeah. Let's do like one or two then. Like I won't be turning this in, so it doesn't really matter.
Sure, but you might get this on a test or quiz and you'll just be that much further ahead. So does
Yeah, so I
does
think
one stand out to you, like 14, 15?
how about 15, 16, 15 and 16 seem like
Okay, so let's take a look at
like
those.
the longer ones. What do you think like I'll be seeing in the future like after this? Because maybe we can do like get a little glimpse into that before I actually get it.
Probably systems of equations.
All right, maybe we can like scrape the surface on that after this.
Absolutely. Okay, so when I look at this, I remember I said if you see a number and all the other ones have denominators, you want to write that in, or at least visualize it. So you're trying to find the LCM
And the
of,
LCM would be 15 for this problem.
yes. So other than there just being a lot, oh, and it happens to be right there, 15. Yeah, be careful not to multiply that in. I've just seen that happen over the years. So,
Oh man.
okay, so this is 3m plus 10 minus 30 equals
30.
15m,
Wait, why would that be 15m?
because you got to multiply everything.
Oh,
There's
right.
1, 2, 3, 4, 5 terms here.
I don't know why I was thinking it had to be 30. I think it was just because he said 30 before for whatever reason. And
Okay.
then
So now I would combine like terms. You did that in a previous problem. That was pretty good.
I'd say bring over, subtract like 15m.
Yeah, and I mean you can do that. I was suggesting like you just combine stuff, but yeah, now now you
So
subtract
add
50.
20 and subtract 15m.
That's right.
3m minus 15m and minus 6 plus 20, which would give you negative 12m, and negative 6 plus 20 would be 14.
Yep, and then you divide by negative 12. So m equals 7 over negative 6.
All right, so this is basically the same exact thing.
Yeah, more complicated. I mean, your instructor said it. So why don't you try 16 on your own? And if you get this down perfect, which I think you will, we'll just move on to systems.
Awesome.
And see what we do next. So,
all right. All right. Oh, sorry. I think I got it.
why don't I just write out some of the steps here in case you want to look at this later, and then you can tell me if there's any issues. Okay, so like you said, you told me before, you subtract and add.
Oh wait, I already see an error I made.
Oops.
I wrote
What's the error?
Instead of writing +4, I wrote +12.
Okay.
I don't know why I did that.
Well, it's a lot going on here. You got a lot of operations. You know.
All right, wait. Let me redo that super fast.
Okay.
+4, and then that would be, instead of 48, that would just be 40. And then you'd have, okay, yeah, I got it.
And you divide by minus 15. This time you actually have to reduce these. So
8 over 3.
yes.
Oh, well, minus 8 over 3.
All right, very good.
Okay, cool. Well, it always feels good, like, understanding the thing we do.
Yeah, now I do feel like there's going to be something else there, but I can't tell you off the top of my head what it could be. So just don't say like I got it. Those are your famous last words if you say that.
Yeah, that's true.
All right. Okay, so let me I'm going to snip in. This is a worksheet I've been working on for a while now. It's perfect though for what you're asking for, which is systems of equations. So we're going to look at a couple of examples here. There's actually several ways to solve systems, but we're going to work on elimination tonight.
All right.
Maybe you've seen this. Sometimes they cover this in a previous math class, but the very first type of system using the method of elimination, the very first, like, and this is like what you should learn to do. This is like your steps. You always try to just add. And literally, like, you add the system together.
All right.
Okay. So like you add vertically. So what is 2x minus x?
X.
Okay. What is y plus negative y or y minus y?
0.
0.
I mean,
so you can choose to write it or not. What is minus 7 plus 6?
A -1.
-1. So a system of equations, in this case, it's 2 lines. So 2 lines intersect at a point. So your solution is not x equals 1, -1. You need a y value as well. So to get your y value, you have to put this x back in one equation or the other. Let's put it back in the first one.
All right.
2 times -1 plus y equals -7. So this is -2 plus y equals -7.
Y equals -5.
y equals -5. So you either go ahead.
Always logical. So would I always put it back in that first row?
No, you choose the one that's easier. So
Okay,
see how you get a
so
little choice here again?
logical approach.
Yeah, and there's good choices and bad choices. If I always like to reference, if you've seen Indiana Jones and the Last Crusade, where they're at the end where he's got to choose the cup. You know, got to choose wisely. Could be good or bad. Now, your instructor either wants the following: they either want a nice, compact, here's your solution, or they want it as an ordered pair. But what they do not want to do is they don't want to have to search your work. So you have to give them one of these.
What your answers are.
Make it very clear because there's a lot more work now.
And then would I place that onto a graph?
Only if it said to graph the solution.
Okay.
This worksheet, we're just finding the numbers. Okay, so on the right here, we're going to do another example here. We're going to just try adding because that's what the instructions tell you. They tell you the type. 2x minus x is x.
Oh, sorry. X and then the y's cancel each other out, equals 4.
4. Okay. So now you have to choose.
4.
You either put 4 back into the first equation or the second. I would argue the first is slightly better because it's got positives, but it's your choice.
So then 2 times 4 plus y equals 11. 2 times 4 is 8 plus y equals 11. Subtract 8 from both sides. Y equals +3. And the ordered pairs would be 4 and 3.
Perfect. Okay, so you watched me do 2 examples and you basically did the second. Let me have you can pick here. I'm going to snip in 2 more questions before we move on to a harder one.
All right.
And you can just pick one or the other and just solve it, whichever one you want.
Okay, so when there's the x's cancel each other out, we'll be solving for y instead. So then,
that's correct.
All right. Y. I'm not super sure if I got it, but
which one did you do, 3 or 4?
I did 3.
What is your answer to 3?
Y variable is -3.
What about x?
X variable is also -3, or
Okay,
like +3.
So a lot of uncertainty here. So here's how you check. You check by substituting them. They have to work in both equations. So -3 plus 3 times -3 has to equal -6. That's me checking the first equation. Okay, and this is a question mark here. It's like, is this true? Well, I don't know. -3 is 3. 3 times -3 is -9. Is 3 plus -9 -6? Yes.
Yes.
So that worked. But now we have to checking in the second equation. Okay, so that's -3 because that's x minus 2 times -3. Does that equal (3)?
Yes, it does.
So this is -6. -3 plus 6 equals 3. You got it. Okay, so this is not very difficult. Would you agree so far?
Yeah, so then
there's more types though. So the way I teach math, and you're getting a little glimpse into that right now, is I break down topics that you're learning into systematic ways of learning it. Like, do you feel like you understand the add method now of elimination?
Yeah, I think I understand that.
Okay, well, guess what the next one is?
Subtracting.
Subtracting. Okay, it's not all that exciting, but it's very clear what to do here. Now, I have to show a little bit of work for each of these. I write kind of big, but you're subtracting the second equation. So there are kind of a couple ways to do this. One way is to literally read it off like line by line, or term by term. 2x minus x, that gives you x. y minus y is
nothing.
0. And then 9 minus 5 is
4.
4. Okay. Now, alternatively, you could do the following. You could actually distribute the negative to everything. So it'd be negative x minus y equals minus 5. And then you can do just like you did in the first problem. You can add.
Yeah.
So you get x plus 0 equals 4. So it's up to you.
Whatever floats your boat.
Whatever you like. See, that's the theme for tonight is like, hey, you get to decide some stuff now, which can be good. I mean, it frees you up from always having to use these rigid rules. But regardless of which one you choose, you get x equals 4. Now, this is key. You always go back to the original system when you're solving for the other variable. Do not go back to an intermediate result.
All right.
Okay. Now, my choice this time would be to go to the second equation. I choose that because it looks simpler to me. But maybe if you see that, you say, oh yeah, that kind of looks better to me. So then you subtract 4, and y equals 1. So x equals 4, y equals 1.
Y equals 4, y equals 1. I mean, x equals 4, but.
Sorry, x equals 4, y equals 1. Okay, now let's look at this next example over here on the right. Okay, and again, you have a choice here. You can either, and you don't have to even write this. You can actually just start doing it. But as a first-time system student, you might want to write out a few of these. I prefer to do 2x minus x, y minus y, 11 minus 8. All right, that's my preference. But you can also distribute the negative in and then add. What do you want to do here? It doesn't matter to me. It's whatever you want.
Let's just do it that way, because I guess like if you're saying it out loud, it can make more sense.
2x minus x is x. Y minus y is 0. 11 minus 8
is 3.
So x equals 3. Okay, so now which equation are you going to go back to and try to?
The top one.
Top one. Okay.
So then when I make it 2 times 3 is 6, and then y equals 11 minus 6, which equals 5. Y equals 5. Okay. I think that was what I was confused on the other part, was just that final part.
Yes. Okay, so let me give you a more difficult one than this. So you can just get kind of a sample here of like what, it's not going to be that much more difficult, but it is different than, subtracting is harder than adding. We can say that definitively because we're less comfortable with it. So I want you to pick 19 or 20. Doesn't matter to me which one you do. But I want you, I'm sorry?
We can just do 19.
Okay, so for 19, I want you to subtract. Use the method of subtraction here.
So would y equal 1?
So when you subtract, you get y on the left and then 1 on the right. Yes.
Okay, and then I guess I'll just put it into the top. So then 2x minus 3 equals minus 5. 2x equals minus 2x equals minus 1. And then the variables would be x is -1 and y is +1.
Very good. Okay. All right, so if we're going to do the one on the right here, when you subtract, okay, the way this works is 3x minus 3x, that goes away. Now you got to be a little more careful with your signs. Minus 5y minus a minus 9y becomes 4y. Minus 29 minus a minus 69 becomes 40. So it is not always the case that you just get the variable, although it happens a lot in the ones we've been working on. But you may have to do that additional step there.
All right.
Now, which equation, and I want you to do this, put this 10 back in either the first one or the second one, it doesn't matter, but get me that other variable, please.
Sounds good. X equals 7.
Very good. Okay, we have just enough time to cover the next type. There's only 4 types. You can actually cover math pretty quickly when you understand it the way you do tonight. It really goes fast, which is great to see. This is what's possible for you, Zach. Really is. Okay, so here again, this type tells you need to multiply, then add. So it's a little different. It's like, oh, can't just add, can't just subtract. Like, notice if you were to add these, you would get x plus 5y equals -8. And that's no good, because the method of elimination, which is what we're doing, it requires you to actually eliminate a variable.
Yeah.
Okay. So now this is where you need a little more guidance. So I'm going to multiply the second equation by 2.
Okay.
Right? And you'll see why here in a moment. So the first equation is, go ahead.
Well, would it make sense if we multiplied the top by 3, which would make the final part also -6? Or
you want to eliminate a variable. So the variables, and this
or
is what
X
this
and
is.
Y. Oh, right. Yeah. Variables are.
And this is where we need more time than we've got here. But
Yeah.
there's this like where I have to convince you why you add and why you subtract, which we're not doing. I'm just telling you what to do. Part of the learning here is knowing when to do it and why to do it. So currently, okay, you can now add these. Like, because of this multiply step, now you can add. And notice that one of the variables gets eliminated.
Yes.
I mean, in some ways, I'm like pulling the wool over your head, like that expression we know to mean, like, I'm not giving you the full information here, but it will come.
All right, sweet. I guess maybe for our next meetup, we can try and go over this a little bit too, depending on
Absolutely. And maybe you'll have already seen it in class by then. But great job today. It's always great when we get to dive into some new stuff.
Yeah.
Thanks so much for scheduling. I'm going to send you the notes here shortly, and
All right,
I'll see you next time. Have a great night. Bye now.
All right, yeah, you too, Matthew. See you.